Alright, in today's lesson we're going to talk about Oreo cookies and what they have to do with chemistry. And the concept today is called percent composition, and it's a way to determine how much each element takes up in a compound. But let's look at Oreos. Here I have a picture of some single stuffed and some double stuffed Oreos, and what the question I ask, and then this is an activity that you'll have a chance to do in class, is, are double stuffed Oreos truly double stuffed? And there's a couple ways you could measure this, or there's a couple ways you could report this. You could just measure the stuffing in each, right? And we could measure the stuffing and say the double stuffed has 2 grams of stuffing and the single stuffed has 1 gram of stuffing, and we could say that they truly are double stuffed. But let's say that it's not that clear. Let's say that this one has 2 grams of stuffing and this one has 1.5 grams of stuffing. Well, you might say, well, this is a ripoff. This is a travesty. It's not double stuffed. But there is a way that it could still be double stuffed, and that's if we found the percent of stuffing in each Oreo cookie. And if we were going to do that, you might think, well, what do we need to know about each cookie? Well, we need to know how much stuffing is in each cookie. And the other thing we would need to know is how much each cookie weighs. So if we did this cookie, let's say 2 grams of stuffing divided by the total mass of the double stuffed Oreo, and let's say that the total mass of the double stuffed Oreo is 4 grams, and then we did this one and we said that this is 1. So in this case we see that 50% of the double stuffed cookie is cream, right? And that makes sense intuitively. 2 grams of cream, the whole cookie is only 4 grams, so half the cookie is cream. If we do this calculation, we get 0.3, which if we multiply by 100 to turn it into a percent, we get 30%. So by this measure, this cookie is 30% cream, which isn't double stuffed. So there's a couple ways the cookie company could represent their data, and the way we're interested in is using this method, which is finding the percent of the cookie that is cream. Okay, so the percent composition of a substance is the mass of an element in 1 mole of that substance divided by the molar mass. And this equation here, let's take a look at how to use it. And this is America's favorite recreational molecule. This is ethanol, otherwise known as vodka or rum or brandy or marinara, or you name it, whatever your parents drink. So in this, let's find the percent of each element. So the way we're going to do this, first, to find the percent of carbon, we need to first find the mass of carbon in the element, or in the compound. So we have 2 carbons. So if we look on the periodic table, we see the mass of carbon is 12. So 12.01, but there's 2 of them, times 2, divided by, we need to find the molar mass of this compound. So let's do that calculation first. We've got 2 carbons, 6 hydrogens, and 1 oxygen. And if you do the molar mass calculation for this compound, you get that this compound has a molar mass of 46.07 grams. Okay, so put a little box around that to keep that number handy. So to find percent carbon, we're going to take the mass of the carbon and 1 mole of this substance, and then divide by 46.07. And then multiply that by 100 to get it to a percent. And we do that, and we get a percent carbon of 52.14%. So now let's find percent hydrogen. So now again, what's the total mass of the hydrogen? Well, if we look up here, we see that there are 6 hydrogens. So 6 hydrogens would give us a total mass of 6 grams in 1 mole, divided by 46.07 times 100, and that gives us a percent of hydrogen of 13.13%. And then finally, let's do our percent oxygen. We have 1 oxygen, so that's 16 grams divided by 46.07 times 100. And for the oxygen, we get a percent mass of 34.73. Okay? And to check your work, right? These are the only substances, the only 3 substances in the compound. So we should, if we add these up, they should equal 100. So we can do a quick check, and when we do add these up in the calculator, they do in fact equal 100%. So that tells us that we're done, and we have our answers. So that's how you do a percent composition problem. They're pretty straightforward. So now you can practice.